Reflection often improves the performance of the system, but before I commit to keeping it, I would usually want to double check how much it actually improves the performance because it does slow down the system a little bit by needing to take an extra step. Let's take a look at evals for reflection workflows. Let's look at an example of using reflection to improve the database query that an LM writes to fetch data to answer questions. Let's say you run a retail store and you may get questions like which color product has the highest total sales. To answer a question like this, you might have an LM generate a database query. If you've heard of database languages like SQL, SQL, it may generate a query in that type of language, but if you're not familiar with SQL, don't worry about it. But after writing a database query, instead of using that directly to fetch information from the database, you may have an OM, the same or different OM, reflect on the version 1 database query and update it to maybe an improved one, and then execute that database query against the database to fetch information to finally have an LM answer the question. So the question is, does using a second LM to reflect and improve on the database or SQL query actually improve the final output? In order to evaluate this, I might collect a set of questions or set of prompts together with ground truth answers. So maybe one would be how many items are sold in May 2025? What's the most expensive item in the inventory? How many styles are carried in my store? And I write down for maybe a 10, 15 prompts, the ground truth answer. Then you can run this workflow without reflection. So without reflection would mean to take the SQL query generated by the first OM and to just see what answer it gives. And with reflection would mean to take the database query generated after the second OM has reflected on it to see what answer that fetches from the database. And then we can measure the percentage of correct answers from no reflection and with reflection. In this example, no reflection gets the answers right 87% of the time, with reflection gets it right 95% of the time, and this would suggest that reflection is meaningfully improving the quality of the database queries I'm able to get to pull out the correct answer. One thing that developers often end up doing as well is rewrite the reflection prompt. So for example, do you want to add to the reflection prompt an instruction to make the database query run faster or make it clearer? Or you may just have different ideas for how to rewrite either the initial generation prompt or the reflection prompt. Once you put in place evals like this, you can quickly try out different ideas for these prompts and measure the percentage correct your system has as you change the prompts in order to get a sense of which prompts work best for your application. So if you're trying out a lot of prompts, building evals is important. It really helps you have a systematic way to choose between the different prompts you might be considering. But this example is one of when you can use objective evals because there is a right answer. The number of items sold was 1,201 and the answer is either right or wrong. How about applications where you need more subjective rather than objective evaluations? In the plotting example that we saw in the last video, without reflection, we had the stack bar graph. With reflection, we had this graph. But how do we know which plot is actually better? I know I like the latter one better, but with different graphs varying on different dimensions, how do we figure out which one is better? And measuring which of these plots is better is more of a subjective criteria rather than a purely black and white objective criteria. So for these more subjective criteria, one thing you might do is use an LM as a judge. And maybe a basic approach to do this might be to feed both plots into an OM, a multimodal OM that can accept two images as input, and just ask it which image is better. It turns out this doesn't work that well. I'll share even better idea in a second. But one thing you could do might be to also give it some criteria by which to evaluate the two plots, such as clarity, how nice looking they are, and so on. But it turns out that there's some known issues with using LMs to compare two inputs to tell you which one is better. First, it turns out the answers are often not very good. They could be sensitive to the exact wording of the prompt of the LM as a judge, and sometimes the rank ordering doesn't correspond that well to human expert judgment. And one manifestation of this is many LMs will have a position bias. Many LMs, turns out, will often pick the first option more often than the second option. And in fact, I've worked with a lot of LMs where given two choices, whichever choice I present first it will say the first choice is better. And maybe some LLMs prefer the second option, but I think most LLMs prefer the first option. Instead of asking an LLM to compare a pair of inputs, grading with a rubric can give more consistent results. So, for example, you might prompt an LLM to tell it, given a single image, assess the attached image against the quality rubric, and the rubric or grading criteria may have clear criteria like, does the plot have a clear title? Are the axis labels present? Is it an appropriate chart type? And so on, with a handful of criteria like this. And it turns out that instead of asking the LLM to grade something on a scale of 1 to 5, which it tends not to be well calibrated on. If you instead give it, say, 5 binary criteria, 501 criteria, and have it give 5 binary scores, and you add up those scores to get a number from 1 to 5 or 1 to 10 if you have 10 binary criteria, that tends to give more consistent results. And so if we're to gather a handful, say 10, 15 user queries for different visualizations that the user may want to have of the coffee machine sales, then you can have it generate images without reflection or generate images with reflection and use a rubric like this to score each of the images to then check the degree to which or whether or not the images generated with reflection are really better than the ones without reflection. And then once you've built up a set of evals like this, if ever you want to change the initial generation prompt or you want to change the reflection prompt, you can also rerun this eval to see if, say, updating one of your prompts allows the system to generate images that scores more points according to this rubric. And so this too gives you a way to keep on tuning your prompts to get better and better performance. What you may find when building evaluations for reflection or for other agentic workflows is that when there is an objective criteria, code-based evaluation is usually easier to manage. And in the example that we saw with the database query, we built up a database of ground truth examples and ground truth outputs and just wrote code to see how often the system generated the right answer in a really objective evaluation metric. In contrast, for more subjective tasks, you might use an LM as a judge, but it usually takes a little bit more tuning, such as having to think through what rubric you may want to use to get the LM as a judge to be well calibrated or to output reliable evals. So I hope that gives you a sense of how to build evals to evaluate reflections, or more generally, even to evaluate different agentic workflows. Knowing how to do evals well is really important for how you build agentic workflows effectively. And you hear me say more about this in later videos as well. But now that you have a sense of how to use reflection, what I hope to do in the next video is a deep dive into one aspect of it, which is when you can get additional information from outside. And this turns out to make reflection work much better. So in the final video of this module, let's take a look at that technique for making your reflection workflows work much better. I'll see you in the next video.